Alright, so the next code we're going to be looking at is what we call XS3, and it's also a BCD code, binary coded decimal. So it means we're going to be coding each decimal digit into this code. So there will be 10 different codes. And then another name for it, or another way of writing it, I should say, is XS3 BCD. So whichever way they show it to you in the question, that's the same thing. So we're going to be converting this number, the same number we're using for all the examples, so you can see the differences. 263,48, and we're going to convert that to XS3. And it's a very simple code to do. So here's the number, and what we're going to do is to each digit we're going to add 3 to it. So I'm going to write it like that. So then I can just add these numbers up. So the first one, 2 plus 3 gives you 5. 6 plus 3 gives you 9. 3 plus 3 gives you 6, comma 4 plus 3 gives you 7, and 8 plus 3 gives you 11. Alright, so now what we do is we're going to use 8421, and we're going to convert these numbers into binary. So I'm not going to well, let me do it. So let me write here 8421, 8421, 8421, 8421, 8421. All right, so I've written them in small underneath there, and then we can just convert them into binary. So 5, I'm going to use the 4 and the 1, so that's going to be 0, 1, 0, 1. The 9, I'm going to use the 8 and the 1, so that's going to be 1, 0, 0, 1. The 6, I'm going to use the 4 and the 2, so that's going to be 0, 1, 1, 0, comma. For the 7, I'm going to use the 4, the 2, and the 1, so it's going to be 0, the 4, the 2, and the 1. And for 11, I'm going to use the 8, the 2, and the 1. So 8 plus 2 is 10, plus 1 is 11. So I'm going to use 8. I'm not going to use the 4. I'm going to use the 2, and I'm going to use the 1. And then I'm going to write here, I'll just make it in short form, XS3. So we can see that that's in XS3. And again, remember, do not clean up the number. Do not erase this 0. No, don't erase any zeros in the front or the back. Leave it as it is, because that's a code. So that's how we convert a number. And I just want to show you this very quickly at the end. So here again, 0 to 9 in decimal, and you can see each digit we've added 3 to it. So the 0, we said 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5, and all the way down, 9 plus 3 is 12. So we just added 3 to each number, and then we got a new number. And then we used 8421 to get the binary version of that. So 3, that's 0, 0, 1, 1. And for example, 12 at the bottom here is 1, 1, 0, 0. All right, so I just want to show you this last thing. So you can see this code is also self-complementing. So you can see the two numbers in the middle here, 0, 1, 1, 1, and 1, 0, 0, 0. And as you go out, it's 0, 1, 1, 0, and 1, 0, 0, 1. And the last two, it's 0, 0, 1, 1, and 1, 1, 0, 0. So again, you can write down this code, and then you can check if you are correct by checking that the mirror image, you could say, is the complement. So you could check if this one is the complement of that one, if this one is the complement of that one. Then you'll know that you haven't made a mistake in the code. So I hope that helps. We're going to look at 2 more codes. The next code is called 84 not 2 not 1, and we'll do that in the next video.